So we're going to use differentials to estimate the value of 32.3 to the 1/5 power, and then we're going to compare it to the actual value of it. And first I'm going to find the actual or exact value, which will technically still be approximated by using the calculator. So 32.3 to the 1/5 power is about equal to 2.003736.016, and that number is going to go on forever. But that's going to be a good check for us to make sure that we have this right at the end. So our answer should be really close to that. So our first step is to define what f of x will be, and we can just let it equal x to the 1/5 power. And then we're going to take the derivative, which should be x, a 1/5 x to the -4/5 power. And that means our differential of y there is going to be the same thing as the derivative of x times dx. So I'm going to rewrite the 1/5 x, -4/5 x, 1/5 x to the -4/5 times dx. Now we're going to use our approximation equation. We know that f of x is really x to the 1/5 power. And then I'm going to rewrite what the derivative dx is. So it's going to be 1/5 x to the 4/5 times dx. I'm going to put that down there. Now we want to select a value that's really close to 32.3. Let's select 32 since we know what the answer of 32 to the 1/5 power will be. So if we let x be 32, that makes our dx, which is the differential, how far it is away from 32, going to be 0.3, because 32.3 minus 32 is 0.3. Now we're going to take the values that we know. So 32 is going to go in for the x's, and the 0.3 is going to go in for the dx, and it's going to become a calculation. So it's 32 to the 1/5 power plus 1/5 times 32 to the -4/5 times 0.3. And 32 to the 1/5 power is 2. And 1/5 times 32 to the -4/5 times 0.3 gives us 0.00375. So our linear approximation, after we add those up, would be 2.00375. And you can tell that's pretty close to what the actual value is up there.